Hello guys, today we're going to take a look at another module that was sent into us from icstation.com. So this is a DC to DC converter. It's a step down converter. So what it's supposed to be able to do is take either 24 or 12 volts and reduce it down to a number of 5 volt USB outputs. So you might use that for, say, if you were camping or something, you might bring a 12 volt battery, or if you had a solar panel charging a 12 volt or 24 volt battery system, you could use this to give you a couple of USB ports that you could maybe charge some batteries or something like that. So first thing, if we take a look at the module, we can see that it took a bit of a hit in the shipping. So obviously this little piece of steel is not supposed to be down on top of here, and same at the back, it's got to knock down. So before we can do anything, we better fix that, which presumably is going to be just a matter of pulling the parts back into place, since that's all that happened in the post. So everything feels fairly solid in there. Doesn't look like anything has actually been damaged. So it looks like when the steel came down, it sat on this row of 5 volt USB kind of terminals, which would be fairly strong, and then it sat on the DC jack over here. So pretty sturdy stuff that it was sitting on. Maybe it was sitting on a cap there as well, but yeah, all in all, looks alright. So we have an input here for 2 wires, so you could either put your 12 volt or your 24 volt in there, and we have a DC jack here, which presumably is the same. But we can check that. Actually, we might take this off altogether, and then we'll be able to just check if those two connectors there are joined together. So we have our multimeter on continuity, so we can hear when there is a connection. So let's just check that this DC jack is center positive, which would be probably the most common. So that's is center positive, and the other end should be just ground. So the two contacts on this are exactly the same as this, and also this is center positive, which is probably the most common, so that's what you want to see. A lot of, for example, guitar pedals would come and they would be center negative, and so you plug in like your 9 volt power supply into your guitar effects pedal thinking that it's going to work fine, and it blows up. So it's good to note that, or good to check what polarity that is, or these things are, if you're not 100% certain. But most of the time it would be that way around. So center positive. Okay, well, I have a USB connector that I butchered earlier, and I have 12 volt 5 amp DC connection, so that should work there too. So let's just try this first. We have a little light on there. No smoke, that's a good start. So let's plug this guy in, and now we'll hook up the voltmeter. Okay, so let's hook him up here. This one's ground. This should be VCC. So there we go, 5.2 volts. That's probably not too surprising considering there's no load. So let's load it down a little bit and see what happens then. So we have our little motor there. Well, that made very little difference to it. Although to be fair, that's probably only like a 40 or 50 milliamp load. I think when they're loaded down fully, they're still only about 100 milliamps. Okay, so we'll load it down a little bit. Here's 6 LiPo batteries. And we'll hook up ground over here. Won't have a great connection now, admittedly, so that might skew the readings a little bit. but we'll do our best. Well, that fairly put the voltage down, but still holding up there fairly reasonably at 4.5 volts. That should still be charging those batteries. So maybe we'll take a look at what kind of current has been drawn. Okay, so let's try this load now. See, that's only 1.4 amps. It's not huge. It's a decent load. Like that's this thing is supposed to be rated for 5 volts or 5 amps, 5 volts output, I think. So that's alright, like 1.5 volts going alright. But let's see if we can add a little bit to it. Okay, so I have a little power supply to boost our 5 volts from our USB up to, well, to trying to get to 12 volts to drive this LED array. So it's like a bunch of LEDs on a flexible PCB basically. So what I'm going to do, we're watching the current up here, and I'm just going to increase the voltage here, which will obviously increase the current as we get closer to the designed current for this array of PCBs or of LEDs. So let's just up the current. You can see the LEDs getting brighter. There's half an amp, and an amp, there's 3 amps all of a sudden. That looks to be as high as it goes. So that looks to be it. So 3.5 amps out of our little power supply there is pretty impressive. You'd obviously be able to charge any of your LiPo batteries or anything like that if you were out in the field, which is probably what you'd want to use something like this for, to take power from like a 12 volt battery to recharge your LiPos or something if you were out with, say, RC planes or drones or something like that. So that's all there is to it really. I mean, it seems to be doing what it says on the tin. 3.5 amps is quite a bit, so it's probably as much as you'd want. Whether if you had all 4 of these plugged in, maybe then you'd get up to the 5 amps across all 4 of them, I'm not sure. But I don't have really a way of testing that, so we'll just have to go with the 3.5 amps at the minute. So that's pretty much it. The module seemed to work alright. I can't see any problems with it. If you want to get one for yourself, this one came in from IC Station, so you can head on over to their website and you'll get one. And there's not much more I can say about it, so that's all for this video. Thanks very much for watching. If you liked it, don't forget to hit the thumbs up button, and that's it, so I'll see you in the next video.